How does the brain cause hyperacusis, not just the ears? Imagine hearing everyday sounds and feeling overwhelmed or even in pain. That's what happens in hyperacusis, a condition where normal sounds seem unbearably loud. While the ears pick up sound waves, the brain actually plays a big part in how loud or uncomfortable those sounds feel. It's not just about ear damage or hearing loss. The brain's way of processing sound can change, making normal noises seem much louder than they really are. In hyperacusis, certain parts of the brain become more active than they should be. The auditory cortex, which is the brain's main area for processing sound, can become hyperactive. This means it responds more strongly to sounds, even quiet ones. The medial geniculate body, a part of the thalamus that relays sound signals, and the inferior colliculus, a midbrain center for hearing, also show increased activity. This heightened activity can cause sounds to feel louder and more intense, even if the ears are functioning normally. The brain doesn't just passively process sound. It also uses top-down control, meaning higher brain areas influence how we perceive sounds. The dorsolateral prefrontal cortex, involved in thinking and decision-making, can influence auditory regions. When this control is disrupted or overly active, it can make sounds seem more threatening or intolerable. Emotional responses are also deeply connected to hyperacusis. The amygdala, which handles emotions like fear and anxiety, can become more connected to the auditory cortex. This means that sounds are not only perceived as loud but also linked to feelings of distress or fear. That's why many people with hyperacusis also experience anxiety or emotional discomfort when exposed to certain sounds. Another important factor involves inhibitory signals in the brain. Normally, certain neurons releases chemicals like gamma-aminobutyric acid, or GABA, which help keep brain activity balanced. In hyperacusis, research suggests that these inhibitory signals are reduced. Without enough GABA activity, the auditory pathways become overexcited, making sounds seem louder and more intrusive. Beyond the auditory system, other brain networks involved in attention and sensory filtering also change. These networks help decide what sensory information is important and what can be ignored. When they are disrupted, the brain may overemphasize sounds, making them feel overwhelming. Additionally, connections between the auditory centers and memory or arousal systems, like the hippocampus and reticular formation, can reinforce the perception of loudness and keep hyperacusis symptoms ongoing. All these brain mechanisms help explain why hyperacusis can persist even after the initial cause, such as noise exposure, has gone away. They also clarify why hyperacusis often occurs alongside conditions like tinnitus, anxiety, or other neurological issues. Essentially, the brain's way of interpreting and emotionally responding to sound can amplify and distort normal auditory signals, making everyday sounds seem painfully loud. Understanding these brain-based causes is crucial for developing treatments. While ear health is important, addressing the neural circuits involved can help manage or reduce hyperacusis symptoms. If you or someone you know experiences this condition, it's best to consult healthcare professionals who can evaluate both ear health and brain function. Remember, each person's experience is unique, and effective treatment plans should be tailored to individual needs.